These are some questions about magnetic force that are conceptual in nature. And it's important that you stop each question before the explanation and think about it for yourself and even decide what you think the answer is, even if you're just guessing. Research shows you'll retain the answer longer that way. That if you just go straight to the answer, you most likely won't remember the answer or increase your understanding of the concept. After each question is displayed originally, I will put a screen similar to this one up for 5 seconds. That gives you a chance to pause on your player and maybe even rewind so that you can see the question again and think about it for a while, and then you can go forward and listen to the explanation after this screen for 5 seconds. In this one, we have a magnetic field into the screen and a positive charge with a velocity up. Well, the direction of the force always has to be perpendicular both to the field and the velocity, so you should immediately say, well, if one is up and one is in, then the force has to be perpendicular to both of those. That's either left or right, so immediately eliminate choices 1, 2, and 3. Okay, then if you use the right-hand rule, you say, okay, let's point our fingers in the direction of the velocity with our palm facing into the screen. We get that our thumb is pointing to the right. Here's another. So most people are picking 4D, which is right. So you got it. I mean, this is essentially the same one last time, just rotated 90 degrees. Change it a little bit. You know what? I'm going to change it from what's written down. Let's say it's a negative charge. Okay, this one is a negative charge. It says positive up there, but it's negative. Yes, there'll definitely be a negative charge question on the test. So this time the field's going to the right. The arrows are actually drawn in there. We point our fingers in the direction of V. We curl them in the direction of the magnetic field. And our thumb points out of the page, but that would be the force on a positive charge. I said it's negative, so we have to flip it 180 degrees. And that's up, right, into the page. I've got to flip it 180 degrees out of the page. Okay. Yes, so you're all right. This one. This one, yeah, I was doing this one the other day in my office, and they're like, wait, I don't understand what the magnetic field is. There's no magnetic field. So if there's no magnetic field, there's no magnetic force. I mean, I wouldn't mind if it said, if the question was, the magnetic field is 0, what's the direction of the magnetic force? But as shown, it makes it seem like they just forgot to put it there or something. I don't know, it's not shown. So anyway, yeah, I don't really like how that one was written, but it's 0 if there's no field. And these are ordinary atoms. I'll just specify that. Here's another hint. It's not related to atom or what kind of atom, normal atom. So, it's just ordinary atoms. Also, think about when a charged particle is traveling through a magnetic field, do you expect it to go in a straight line? Or is it a circle or curve or something like that? If you have a charged particle traveling in a magnetic field, it's going to travel in a circle. Right? It's a circular path. Now, it may not be in the field long enough to go in a complete circle, but it's going to bend as if it was going in a circle. Well, the only one of those paths that's bending is 3, but that's not the right answer. I mean, everybody picked either A or B, and I said one of those was right. Well, how could that be if 3 is the only one that's curling, like changing direction like it would have to if it was a charged particle? Well, Is an ordinary atom, is it charged? Same number of protons as electrons. Ordinary atoms are neutral. They're not affected by magnetic fields. So, number 2. If this was on a test and I answered something that was like curling up like that, which would be, if it was charged, if it was positively charged, then it would be going sort of like 1, but in a curl, more like 3, except up. And if I picked something like that and this was on a test, I would argue with the teacher that an ionized atom is still an atom. And if I were the teacher, I probably would say, yeah, you're right. So I wouldn't word it the way they worded it. I might say a neutral atom or something like that. Or maybe an oxygen molecule, or, something that made it clear that I wasn't talking about something that was ionized. But if it's not ionized, it's not affected.